steps. Second is the increased operation pausing time due to the difficulty in integrating multiple information. For example, when images from multiple angles are presented, if it is difficult to understand the connection between the images, the operation will pause every time the gazing image changes. Next, I will explain the concept design of the visual presentation method. There are two keywords that can be used to describe the cause of cognitive tunneling. First, visual momentum is a concept used to measure how visual scene transition impacts the user's ability in extracting and integrating information across multiple displays. Comparing the two images above and the two below, the upper one is easier to understand. So we call the upper one with high visual momentum. Next, images that easily attract people's attention are called images with high visual saliency. So above, we set two design requirements to improve visual momentum and to guide users' attention from images with high visual saliency to the low one. Next, I will discuss the detail of the design. Firstly, there is a previous research on operating efficiency showing that different work states have different use landmark as these four states here. Meanwhile, visual momentum is shown to be improved by imaging the same landmark from different angles. Therefore, we designed to present images of useful landmarks from different angles for each work states. This is a visual presentation we designed and applied into experiments. The landmarks mentioned are circle. And next is designed to guide the operator's attention to the external view images. The human visual field can be divided into three main categories: focused vision, effective field of view, and stable field of view. In the method proposed in this study, we placed the images of external view into the effective field of human's view, where a human can instantly move his or her gaze to. In addition, based on the findings, the vibration stimuli affect most in the effective visual field, we decided to vibrate the image at about 5 Hz when the external view image appears. This video shows the visual presentation method we developed. You can see that the presented image switches according to the working states. As explained, each time a new image appears, the image vibrates at 5 Hz to guide the gaze. Finally, I would like to talk about the evaluation test of the proposed visual presentation method we have developed. We verified the effectiveness of the proposed method by comparing it to the conventional one. Also, by analyzing operators' gaze, we confirmed whether cognitive tunneling has been reduced. This is the same environment we used. This is a comparison of the conventional method and the proposed method. And down here is the heavy machinery used and the remote control room. This slide describes the test field and the task. Task is to drive on an L-shaped course made up of traffic cones and perform two manipulation tasks. Also, after the second manipulation task, the operator was asked to repeat the tasks in a reverse order and finally return to the start point. Here are the results of the gaze analysis of the experiments. We focused on mainly two parameters of operator's gaze. First, from the number of times of gaze switching from the cab view image, we analyzed whether the attention could be guided to the images with low visual saliency. Second, from the number of times of gazing image switching, we analyzed whether cognitive tunneling is improved and multiple images can be referred to. The result based on 2 of 4 subjects are shown here. As we can see, both parameters increased significantly. This suggested that the attention could be guided to external view images and cognitive tunneling may also be reduced. Next, we will introduce the result of work time. There was no significant decrease in work time for all work states. As a possible reason for that, we consider that in the conventional visual presentation method, all the images were presented at all the times, so operators might understand the images subconsciously. On the other hand, in the proposed method, when the images were switched, it might take time to understand the contents of the new images, which may have led to an increase in the work time. Finally, this is the result of the placement accuracy and the number of false contacts. The placement accuracy and accuracy did not decrease significantly, nor did the number of false contacts. Reason for that is considered here. As this figure shows, when controlling a heavy machinery, frequent gaze shift is required even in the same work states as grasping to check both the left, right, and depth direction. However, in our proposed method, gaze shift was only supported when work state changes. This might lead to the inefficiency. Therefore, in order to improve the work accuracy, it may be necessary to support gaze guidance in the same work states. This is a summary of my research, all of my presentation. Thank you for listening.
Thank you so much, and I will keep the floor for any question, please. Okay, you can write it on the chat group, and we can read it for Dr. Takumi.